Hey everybody, so we are going to be talking about central angles and arc measures today. So I want to remind you that a central angle happens from the center and it creates an angle right here. That 84 would be a central angle. The arc would be right here, which is AC, and this would be a minor arc since it's less than 180 degrees. And your major arc on here would be arc ADC or CDA if you're going clockwise. And that's because it's more than 180. So if you want to write that in, you can. Major arc would be arc ADC. And your minor arc is arc AC. And it's just kind of like an upside down U or an upside down parabola on top of those. All right, so like I told you, a central angle is an angle with its vertex at the center of the circle, and its two sides are going to be radii. Remember, that is the plural for radius. If you have more than one radius, then it's going to be called radii. The sum of all central angles in a circle is 360 degrees. Pretty much what that means is that a circle on the inside is 360 degrees. So an example of a central angle on the circle you've been given is angle ABC. So if you're highlighting and color coding on here, that would be this one right here. The degree of the arc formed by the endpoints of a central angle is going to be equal to the degree of the central angle. So pretty much the degree of the arc is equal to the degree of the central angle. So the measure of arc, minor arc right here, AC, it's going to be just 84 degrees. It's going to be the same as that central angle that's being created. And to find out what the measure of arc ADC would be, we know the entire circle is 360. So we would subtract 360 and 84, and we get 276 degrees. And so that would be the arc and central angle measure. If you want to highlight that, you can. You don't have to. All right, so what's going to happen is there is one problem, two problem, one problem, two problem. In most of these sections, I'll do one. You're going to be responsible for the other one. All right, so I am going to do number one with you, and you will be responsible for doing number two. You will be inputting that answer in later on. So let's look at it one at a time. And what I would recommend you actually do is I would say you ignore all of what it's asking you. And we'll get back to it later. So I only want to know what I have been given. I know that angle JNK, the central angle here, is 21. And because it's vertical to here, this is also going to be 21 degrees. So yes, we're going back to all of those angles that you guys love so much. Okay, so this is 21 degrees. I want you to notice right here that this is 180 degrees because it's a semicircle. It's half of it. So this one is going to be whatever 180 minus 21 is. And that gets you 159 degrees. The same thing is happening for angle JNM, and it's also a vertical angle, which means it's congruent. So this is also 159 degrees. So if you want to make your congruency markings, you can. And now that you've got all of this, you can just fill in these blanks. The first thing they ask you for is for arc JK. Arc JK right here. Remember, it's going to be equal to your central angle, so it's just 21 degrees. Next, they asked us for angle JNM? Well, we have that, and we know that it's going to be 159 degrees. Now, I'm doing different colors for each of these answers. You do not have to do that, and I urge you not to do it for this one, but it helps me show it to you digitally. Then we've got arc KL right here. And in this case, arc KL, that is actually a minor arc because it's less than 180. Even though it's a super large arc, it's still less than 180 because it's 159 degrees. So there you have it. All right, so now arc JKM. What they are asking us for arc JKM is we're going J to K all the way over to M right here. So we're going to be adding this 21, and this 159. So we're going to get 159 plus 21 plus 21. And that gets you approximately, or exactly, sorry, 201 degrees. And you can check my math on that one if you'd like. All right, and then finally, we've got the measure of arc, and that's a major arc because it's got 3 capital letters, M, K, L. So it's asking for everything except for this little bitty corner. So instead of you doing 159 plus 21 plus 159 and finding that total, why not just subtract 21 from 360? It'll end up giving you the same answer no matter what, which will be 339 degrees. All right, so look at how I've worked this, and I want you to use that and apply it for number 2. You're going to plug those answers in. When you plug them in, you'll find out if you're right. All right, let's do number 1 on this side. Sorry about that. Okay, same thing here. You are going to be responsible for number 2, and I am going to do number 1 with you. So number 1, we are solving for x. What I would look at is what I can create with what they've given me. I know these two are vertical, and I know these two are vertical, which means they're also congruent. Okay, but what if we use what we know about a circle? And we use this diameter RT to find that we have a semicircle here. Arc RST, major arc right here, is a semicircle, and it's 180 degrees. So if we add up arc RS and the measure of arc ST, you will get arc RST. Or in other words, 15x minus 26 plus 26 is going to get me 180 degrees. All right, so I get 15x. These actually end up canceling out. It's kind of nice when they simplify. And it gets you 180, which means you divide both sides by 15. And that means x is going to equal 12. And it's really that easy. You're just solving equations all over again. All right, so you are responsible for number 2. I do want to point out, check out your vertical angles. Remember, use those diameters to help you. Hint, hint. Just drew it for you. All right, next we're going to talk about the actual arc length. We know how much it measures, which is the degree. The length of it is how long it is. So part of the circumference. You'll remember we did sector areas. So that same thing is going to happen here, and we're going to do arc length. Okay, so the length of an arc is a portion of the circumference. It's a proportion that you can also set up. The way that we symbolize arc length is this L right here. And it's a curly L, it's a cursive L. All right? There are two ways you can set it up. All right. So the length, your arc length, is part of the entire circumference, C, and it's equal to x over 360. And then you set it up as a proportion, and then you solve for x if you need to, or vice versa. I want to remind you that your circumference of a circle is 2 pi r, or it can be pi d because your diameter is made from 2 times the radius. Now, another way that I like to do it, you ready? I like to set it up this way. And it's easier, and it's similar to the sector areas that we talk about. So your arc length is going to be whatever your degree is, all over 360 times your circumference, or 2 pi r. Remember, this is circumference. I'm just writing it out because it's easier for me to plug in, and it's easier for me to find my exact answer this way. All right. So I am going to do number 1 with you guys, and you guys will be responsible for number 2. I promise you, it looks hard, but it's really, you've done this. It's just proportions. You can do this. Whoop. All right. So let's look at what they've given us. EB is 15. Find the length. We're looking for arc CD right here. So let's see what we've got. They've told us that EB is 15 centimeters. And I know that the measure of arc BC right here is 68. I know the measure of this entire arc BCD is 180 because it's half. So I can figure out that this is going to be 180 minus 68, which is going to get you 112 degrees. Now you can use this to solve. So your arc length is equal to the measure or part of sector that you're looking for, all over the total degrees in a circle, times 2 pi in your radius, which your radius is 15 because it's going from the center all the way to the circumference right here to that perimeter or that edge. All right. So what I like to do is I'm just going to set it up like this. 112 times 2 times 15. And I leave the pi all the way at the end so I can keep it in exact form. And what I'm going to do, I'm going to pull up my handy dandy calculator right here. If you've got your TI-84, this will be really helpful for you to go ahead and keep it in exact terms and help you simplify it. So we're going to do 112 times 2 times 15. And that gets us 3360 pi all over 360. And that's going to be in centimeters because we're working with a length. So PAV 1, 2, 3, that's where this comes in. So I know this can simplify because I can tell by looking at the number they both end in zeros. So what I'm going to do is I'm going to type it in as a fraction, and that's going to be alpha y equals, enter, 3360 over 360. Now, when you type it in onto your TI-84 calculator, it will pop back an actual fraction for you. I'm using kind of an off-market TI-84 for my iPad, so shh. If you're using the same one, by the way, just click math, and you see that first option there in pink? You're going to click that, and it converts it back into a fraction for you. So now we've got 28 thirds. And so that means we've got 28 pi over 3 centimeters as our exact answer. Remember, if you're typing this in to the calculator, or sorry, online, like this. All right. And then all you're going to do is we're going to type it into our calculator. So I'm going to do alpha y equals, enter, set it up as a fraction, 28 pi, and that's second, and then the caret button so that I could get that pi, type it in, and I'm asking you to round to the nearest hundredth because it just gives it closer to more exact than not, and that's approximately 29.32 centimeters. And these, either one would be the answer depending upon what I ask you. So make sure you're using the pi button right there, second caret. All right. Now, if that doesn't work out for you, fine. Okay. But all calculators have that pi button. Do not use 3.14 unless otherwise told. All right, so you are responsible for number 2. And for this one, you should get approximately 27.65 feet. You are responsible for giving me your exact answer. Sorry about that. All right, so for number 3, let's go ahead and find this one as well, and I'll help you set it up, and then you're going to be responsible for number 4 as well. Okay, so that one's yours as well. So VS, right here, the entire diameter is equal to 12. That means our radius is 6, by the way. Oops. Okay. Find the length of arc UT, and we know it's going to be small. So let's figure this out right here. This one, it requires a little bit more work. This entire thing is 180. So that means this thing right here is going to be 180 minus 127, which gives us 53 degrees. And you're like, but why am I doing that? I need to look for this one. Well, yeah, you do need to look for this one, but it's hard for you to do that because you're looking at it from here. You know that this one is 90 degrees, so you need to figure out what this missing portion is. And that missing portion right there is going to be whatever 90 minus 53 is. So we're going to do 90 minus 53, and that gets us 37 degrees. So I want you guys to go ahead and find your exact answer, and your approximate is going to be approximately 3.87 meters. All right, so go ahead and find that one for me. And if you don't set it up right, that's how you'll be able to check it. You are also going to be responsible for number 4. Your approximate answer here is going to be 61.21 inches. You'll notice that they are asking you for a major arc here, K, J, G. Go in the order that they're giving you. For this one, find out how much this tiny little angle is right here. And you can just do that by subtracting 59 from this 85, since these are vertical angles right here. All right, thanks for watching. That's all I got for you.